Okay, so we're gonna let A, B, and C be real numbers so that A does not equal 0 because you can't have a 0 in the denominator spot. The solution of the quadratic equation A x squared plus bx plus c equals 0 can always be put into quadratic formula. We just don't always do it that way because other ways are easier or faster, such as factoring or completing the square, things like that. So if I have solve x squared plus 3x equals 2, how would you solve x squared plus 3x equals 2? What do you have to do first? Subtract the 2. So you would get x squared plus 3x minus 2 equals 0. Is that factorable? Can I multiply something to give me negative 2 and add to give me 3 in the center? 1 and 2. If they're both negative, I would get a positive 2. If one's negative and one's positive, I would get a negative 1 in the middle or a positive 1. So no, it's not possible. Okay, so because of that, I'm going to use the quadratic formula to solve this. Okay, what is the opposite of b? Negative 3. So I'm going to plug all this stuff in. So I'm going to say negative 3 plus or minus the square root of 3 squared minus 4a is what, 1 in this case? Yes. And then c is negative 2, yes. Over 2a. Yes, a is just 1 because the leading coefficient is just x squared, so there's a 1 there. From there, I would start to solve, yes?
Yep.
Yes. So I have negative 3 plus or minus the square root of 9 plus 8. 9 plus 8 is 17. So you get negative 3 plus or minus the square root of 17 over 2. Okay? That is your solution in this case, yes? Okay, so we're going to leave our solutions like that because we don't have graphing calculators. If you had it on a graphing calculator and you graphed it, you could use this button called the trace feature and it would trace to where the zeros are exactly, and it's negative 3.56 and positive 3.56. You can leave your answer like that, or you can change it into 3.56 and negative 3.56. It's up to you, whichever you prefer. Okay? But this is your solution for that equation using the quadratic formula. So if you cannot factor, if you cannot complete the square, you're going to use quadratic formula to solve. Okay? From here, we get, I don't know why this is so like weird and large. Okay. From here, we get two other equations. It says solve 25x squared minus 18x equals 12x minus 9. What do we need to do to this equation first? What do you need to do to that equation? 25x squared minus 18x equals 12x plus 9. You need to what? Get it to equal 0. So I'm going to add 9 to both sides, and I'm going to subtract 12x from both sides. So you should get 25x squared minus 30x plus 9 equals 0. Okay, that's a perfect square. That's a perfect square, yes? But 5 and 3, can that multiply to get me, or can that add to give me negative 30? Yes, but I don't think it would work out to negative. So I have to use quadratic formula, because if you factored that, right, you would have 5x minus 3 squared, yes? But, let me double check. So you do get positive 9, you do get negative 30x, and you get 25x squared. Ooh, it's a beautiful thing. Okay, so I do get all of those. So I could, if you realize that is a perfect square trinomial, you can set it up that way. If you don't realize that, you have to use quadratic formula. So it comes out to 5x minus 3 squared equals 0, which means what are my solutions for x? What are my solutions? How do I figure out what my solution for x is?
Just cycle through 3 bits.
Yeah. 3/5. I set it equal to 0, right, and solve. So then you get,
How do you get rid of the square?
what?
How do you get rid of the square?
Take the square.
What, yeah, you mean to get this right here?
Oh, never mind. It's 0.
And I get that, 3/5. So your answer is 3/5. Now, that technically has two answers on it. Because what's gonna happen is, this is a quadratic, which means it's a parabola. That 3/5 means that since I only have one answer for x, that's the vertex. Okay, so that's a way to recognize that you have the vertex. How do I solve this equation? What do I need to do first? Negative x squared plus 4x equals 5. Subtract 5. So I should get negative x squared plus 4x minus 5 equals 0. Okay, we want to solve this one using quadratic formula. How can I solve using quadratic formula? Negative b, so negative 4 plus or minus the square root of 4 squared minus 4ac, so 4, negative 1, negative 5, all over 2a. Okay.
4 was always positive.
What?
And the 4 AC, I thought 4 was always positive.
No, it's minus 4ac.
Oh, because you always.
Okay, so then I get 16, or I lied, not 16, 16's on the outside. I get negative 14 plus or minus the square root of 16. What's negative 4 times negative 1? 4, and what's 4 times negative 5? So minus 20 over negative 2. So you get negative 4 plus or minus negative radical negative 4 over negative 2. I have a problem. I have a negative where? So what does that mean you have to do? I. What is the square root of 4? So you have 2i. I'm gonna just draw this up here, sorry, I ran out of space. Negative 4 divided by negative 2 is 2 plus or minus, and then you're gonna get 2i, right? But what is 2 divided by negative 2? Negative 1, so you're just going to get plus or minus i. That's what that would reduce to. 2 plus or minus I.
Yeah,
What's the square root of 4? 2. Okay? But I am dividing by a negative 2. What's 2 divided by 2?
well, why don't we do anything with negative 1?
We did. We reduced it down. Negative 4 divided by negative 2 is 2. So you get your answer of 2 plus or minus I, because technically there's a 1 in front of that. Does that make sense?
Yes.
Okay. Okay, now we're gonna get to the part where it talks about the discriminant. That was just a warm-up using the quadratic formula. The discriminant. Gosh dang, why is this so hard? I don't understand what is going on with my computer. Okay, the discriminant. In a quadratic formula, the expression b squared minus 4ac, what's inside the radical, is called the discriminant. Okay? So you need to know that this is the discriminant, because when it asks for you to find the discriminant, you're going to have to use that part of the formula. Okay? So you can use the discriminant of a quadratic equation to determine the equation's number and type of solutions. Okay? So, what that means is this. If I'm given a formula that's in standard form, ax squared plus bx plus c equals 0, if I find the discriminant, b squared minus 4ac, if it is greater than 0, I'm going to have two real solutions. So if I take that section and figure out what the answer is, and it's greater than 0, I have two real solutions. If I take that section, b squared minus 4ac, and set it equal to 0, and there's one real solution, I have, and it's equal to 0, I have one real solution. It is my vertex. Okay? And if I take b squared minus 4ac and it's less than 0, that means I have imaginary solutions. So it's never going to cross the x-axis, okay? So when you have two real solutions, you have two intercepts, x-intercepts. When you have one real solution, you have one x-intercept. When you have imaginary solutions, you have no x-intercepts. So it should help you with when you go to visualize how to graph this. You also have to be able to be given an equation and just tell me off of that equation by using the discriminant. How many real solutions does this have, or how many imaginary solutions, and how many times does that cross the x-intercept? So you're gonna have to be able to list those things. Okay, so then they give us some examples to work with, which I'll just shift this thing over in a minute. Okay, find the discriminant of the quadratic equation and give the type of solutions of the equation. So if I'm finding the discriminant, what part of the equation am I using?
B squared minus 4ac.
Okay, I'm using b squared minus 4ac. Okay, now, that's what I'm using. So over here, what is my b squared? Negative 8. So I'm going to use negative 8 squared minus 4 times 1 times 17. Negative 8 squared is 64. What's negative 4 times 17?
Negative 68.
Which would give me a negative 4 solution. Is that greater than, equal to, or less than
Less than
0? So what type of solution is it?
It is two imaginary solutions.
Two imaginary solutions. Good.
So that, we'll just list that. We have, will we be graphing that later on, or do we have to?
You don't have to graph these ones right now.
Just run
So
it.
it's two imaginary solutions. Do you know what the imaginary solutions are?
Why are we imagining things on that?
Negative 4 and something else.
No.
No?
Remember when I have imaginary, what do I have with it?
No.
Aye.
So your imaginary solutions technically are this. 4 plus or minus I.
Where'd you get negative 4 from?
What?
Where'd you get negative 4?
Because 64 minus 68 is negative 4. That's what's inside the radical. Okay?
Wait, I lost you.
Okay.
Repeat, where's the I? Why is there?
Because I know it's imaginary because this is less than 0. So then if you did the quadratic formula all the way out, you would end up getting an answer of 4 plus or minus I.
Do we have to write like that? Like with the I, or can we just write negative 4 and 2 imaginary?
It depends. If it asks you what are the imaginary solutions, then yes, you have to plug, you have to go back. But you've already done the hard part of the quadratic formula. Okay? So all you have on the outside is the opposite of b, so 8 plus or minus radical negative 4 over 2. And that's how I get 4 plus or minus I, because it reduces down. What?
Is negative, if you put negative 4 or 4, is that the same thing as saying that, or is it like the I make it different?
No, this is a different part of the answer than that negative 4. What?
Can you go back to the slides where it says like if it's less than?
I got you, McDonald.
It's on page 294. The whole chart is on page 294. Does that help you so you
Whatever
can
you
think?
want my notes, if you want to copy it right down.
Okay, now, on B, I have x squared minus 8x plus 16. How would I set that up to find the discriminant?
I have a question.
Negative.
Okay, what, Mallory?
How did you get 4 from negative 4?
Okay, I didn't. I said, if you plug it back into the quadratic formula,
Oh, then you get 4.
then you're gonna have 8 plus or minus radical negative 4 over 2. 8 divided by 2 is 4. The radical of negative 4 is 2i, which reduces down to I.
Oh, I see.
Okay, does that make sense?
Yeah.
Okay. So what did you say I'm doing, Cameron?
Negative 8
Negative 8
minus 4,
squared minus 4.
1 times 1 times 16.
Oh, beautiful. Oh, yes. Okay, I know what this is gonna be. So it's 64 minus what?
64.
Minus 64. Which equals what?
0.
So how many solutions?
2 real.
No,
Oh, I'm just kidding, not,
one real
One real
solution. Okay, and if I wanted to find out what that one solution is, I would then put 8 plus or minus radical 0 over 2. So what's 8 divided by 2?
quattro.
4.
So my real solution is 4. You plug it back into the quadratic formula.
Who cares?
Who cares?
Why is there, why is the answer 4?
Because Brady, I would plug it back into the quadratic formula. Quadratic formula says opposite of b on the outside plus or minus the square root of 0. So that's what I got for that part over 2. What's 8 divided by 2?
Oh.
That's how you get that.
So when you get, one real, you have to plug it back in?
And when you get 2 imaginary or 2 real, you have to plug it back in. Yes,
All of them?
always. But you've done the hard part already because you found the big part that was the square root of b squared minus 4ac. So you found the hardest part
I have a
already.
question. So on the test, how many points would it be if we took off, if we didn't put in the real solution or
Just
whatever?
don't do that.
No, so like you do everything, like you do all the
Right,
steps
right,
and
right.
stuff.
It's
and
probably
you do
like
it.
one of the points out of like 5.
Oh,
Okay. Now, look at the last one. Look at the C. It says x squared minus 8x plus 15. So I'm going to set this one up by saying negative 8 squared minus 4 times a times c. So you end up getting negative, no, not negative. You end up getting 64. And what's 4 times, negative 4 times 15? Negative 60. So you would get 4 as your answer. How many real solutions?
2.
2. So I get 2 real solutions. And then remember, if I plug this back into the quadratic formula, it would say 8 plus or minus the square root of 4 over 2. Well, what's the square root of 4?
2.
So what's 8 plus 2?
2.
Divided by 2 is? And then 8 minus 2.
6.
And 6 divided by 2 is?
3.
So my real solutions are 5 and 3. Okay. So you're using the discriminant, which is just the portion b squared minus 4ac. What?
I don't know.
Okay. So you're using that portion to figure out what the discriminant of things are. Once you figure out the discriminant, you then know how many solutions there are. 2 real, 1 real, 2 imaginary. If anything is less than 0, it's imaginary. If anything's equal to 0, it's 1 real. If anything is greater than 0, it's 2 real.
Get it, 2.
How did I get
Oh,
5 and 3? Because I took the square root of 4, 8 plus 2 is, divided by 2 is, 8 minus 2 is 6, divided by 2 is 3. Okay, that's how I get the real ones. That's what we're gonna work on tonight, that's where we're stopping.
You stop it. Great.
And that's all of 4.8, so it's even better.
Oh, wait, there's still work. Is there, we're not doing something like example 5?
We'll talk about the word problem tomorrow.
Few words.
You're gonna try it tonight by yourself first.
No.
Yes, you are. You're using the discriminant, you'll be fine.
See, what happened was I got